Hello there, and welcome back to LabHub. So in this video, we're gonna talk about the Faraday's law, and this law basically states the relationship between the electromagnetic field and its properties, such as time, amount of loops, and induced magnetic flux. Right? So the formula looks like this. The electromagnetic field equals to negative n amount of flux, amount of loops, like this. The amount of loops times change in flux. Divided by change in time. So what can we get here? The faster the flux changes, the greater the induced electromagnetic field will be. So less time needed, the greater EMF. And what is this stuff? Like, all right, we got a EMF, we got a time, we got amount of loops. What is this stuff? Change in a magnetic flux is basically estimated as this formula. It's a magnetic field times area times cos. Cos of the angle between normal line perpendicular to the face of the coil and magnetic field itself. And to increase it or decrease change in flux, we basically only need to change any of these parameters. So how can it look like? Let's imagine that we got a square coil, and we also got some magnet. So this is our first case, right? In first case, we got a sim coil with some current and all of this stuff. And we got a magnet. So closer magnet we put into this coil. So the closer magnet is, the closer magnetic field here, right? Closer magnetic field, the stronger magnetic field, it means the greater will be delta flux, because we change the magnetic field here in a loop. And in our loop, we get a magnet closer, we're increasing the magnetic field, so the change of flux increases too. And it means that magnetic field increases means increasing of flux. All right, let's take a look at another example. We got another coil, and we got some constant magnetic field here. So it's constant. How can we change the flux? How can we increase or decrease and change the flux? We can basically increase it by increasing the area. So if we like pull the coil on all sides and stretch it, like bend it a little bit, we'll increase the area. Area increase, it means flux increases, it means the electromagnetic field increases. This is the second case. And the third one, we got another coil that lies on a table. And we got some magnetic field falling on it. Let me represent it like this. So we got some magnetic field falling on it. And the angle between them equals 90, right? What if we just a little bit change the angle? So now, since we pulled the coil up, it now falls. It's not falling on it with this angle anymore. It doesn't fall with that. So the magnetic field falls on a loop, goes through it with an angle, like this is the first case, right? And this is the second. So in the second case, falls, for instance, with the 70 degrees. And therefore, we just need to put a new values as a cos into a cos and figure out, is it decrease, increase, or decrease. So this is basically all you need to know about the electromagnetic fields and the Faraday law.